my counterpart is Srihari. Srihari is one of our lead engineering architects and designers in the R&D group still, is that right? In the R&D group inside. So he and I get together to figure out what types of solutions and services and cool things that we can do to help customers in their digital transformations, their DevOps migrations, as well as IT automation visions and plans. And so Lenovo has a really solid, different way of going about it. We don't just talk about it, we actually do it. And we help customers do it. So we, like you guys and some partners, are in our transition too. Whereas people would think of us as a hardware-only company or a server company, or even PCs and Motorola, hey, great. We're actually helping companies innovate how they build and produce code and software, but helping them figure out the process and seeing it end to end, and it truly never ends. So what we're going to talk about here is what we're doing together with Red Hat and our new partner, CloudBees. So Jason's here. Raise your hand, Jason. So you guys have heard of Jenkins, right? Right? Who hasn't, right? Jenkins is great stuff. So we're actually working with them as well on this solution and others that you'll see. So to kick it off, I guess that's going to be me kicking it off, right? So we hear this crazy buzzword, digital transformation, right? It's all great. It's all, what does that really mean, right? And we take for granted the things that we get easily to our desktops, our laptops, our devices, our kids. I can't get mine off the devices. It's really a hassle, but it's really simplified and made our life easy, right? So, the technology of we'll say, initial waves before some of the recent ones, we sell these different apps, right? And we see that there's new technologies and new ways of computing and transmitting, coming through, right? We have a 5G example down in our booth as well. Everybody's been hearing about blockchain. But, at the end of the day, there's new devices, there's new technologies, and there's new ways that they interoperate, right? And so on the outside, it's really easy and cool, but on the inside, of course, it's very complicated. So large companies, this is a study that IDC did this past year, 51% of large companies, I don't know the exact size that they measure them by, but we'll say upper enterprise, have adopted some form of DevOps, or modern software development, right? Trying to get from agile into true collaboration and to true short iterative code development cycles. But what's odd about it is that they've only, on average, moved about 20% of those 10 to 20% of those applications into that modern framework. Why? If you're going to go to those extremes and those principles and re-architect how you do what you do, you're obviously going to want to apply it right through, right? That means there's kinks in the system that are having trouble. So our job is to help them figure that out. Not like those of Accenture these days or others that will spend millions for a select company that groups can afford it and take years to figure it out. We're in a form mass producing how people design and think about how they bring code to market. So this poor guy here, he's obviously not going to win the battle, right? He's, the weight distribution's not to his advantage. But 20% of applications, if that was the crust of it right now. So what that means is we've got a long way to go. Right? How do we do what we do is really determined by our own needs, but it's also very challenging, and we can't do it all ourselves. We need trusted partners to help us. So, of course, inside, right, who's got it the worst? IT's got it the worst, right? This is just an example of all the different things that IT has to wrestle with in saving the company. Anybody read the Phoenix Project? Right, one of my favorites. Like Gene was awesome when you wrote that, right? He gave an example that not only is IT the lifeblood, but they have to save the company, right? And so IT guys, right? How many IT guys here? IT, right? Okay, how many developers, real quick? Okay, all right, so mostly IT, right? So we just save the company, right? So, and that's not really fair because you have all these things to deal with. You've got developers up in the cloud on one end, and you got, trouble tickets over here that don't get filled fast enough for workloads. You've got all these applications support. What do? Got to figure it out, right? And that's the hard part. That's what we help companies do. We help them figure it out. It's not selling you a server. It's not selling you a piece of software, even though some of them are great. Is that right for you? Well, we don't know, but we're going to help companies figure it out. So we started last year on an engineering path. We built a DevOps solutions practice that helps figure this out for clients. In other words, platforms that help them engineer software. The second thing we did was look at the software stack and what we're going to need to bring in. That's why we partner with CloudBees on one end, and you'll see more of that later. But getting through this is really, really hard for companies. And so what do? So we thought, well, you need easy ways to engineer and bring solutions into the fold, right? Stuff that's plug and play to some extent. Not too easy plug and play, but stuff that's not going to be duct taped or glued together, right? Stuff that works together It wasn't meant to work together in today's world, and that's what the industry has done at this point in time. So we set off in this practice to start engineering solutions that could be scalable and scale out and pay as you grow, right? That help you grow to where you need the workloads and the performance capabilities, but all the tools that you love. Because at the end of the day, the IT guys have to sell the developers, don't they? If you put something in there and they don't use it, they're going to kick it back and you're going to be dead. Right? You're going to say, oh, I spent all this money on this, it isn't working, and that's what happens now. Same time, we got to figure out how to get them out of the cloud a little bit for cost savings and security. So we've got a strategy for that too. So we're thinking in line for best for the client. So we also designed some services around this at different levels. There are more coming, but this is what we have today. So software production assessments, we can analyze software pipelines. We can tell you where the bottlenecks and constraints are. We can also give you recommendations on how to fix them. We can fix them for you. You can fix them. Whatnot, but we can give you the real scientific read and do it again, repeatable, so that you can measure your progress to streamlining. Acceleration services, we can help get executives on board on the same team, limit silos, reduce that stuff, get together in a program, and then execute that program. Container and microservices consulting, one of my key partners that does that part of that specialty for us sits on the Open Container Initiative. If you guys are familiar with Linux Foundation, being on the OCI panel is like a good thing. It's like top of the list. Well, those guys are the best in the business. Securing software code is really key too, because I was talking with a major retailer a couple of weeks ago. You guys know them, you buy their clothes. We all wear them. And I said, so what's your development security strategy? Oh, we don't have one. Seriously? You don't have a way? Oh, well, we secure applications. Right, but what if somebody hacks into your application? Who's securing your code and your IP? The attorneys knew about that. They'd be freaked out. They'd say, get a security strategy going. So we have the ability to do security assessments on software code, and we can show vulnerabilities and a path to remediation for that. We also have a product that provides continuous code assurance in the development process. Software Q&A test improvement, we've begun to offer those services as of a couple of months ago, and of course, integration of solutions on site. We pre-engineer all the solutions. You can get them in pieces and software, like we can get Jenkins Enterprise individually, if that's right for you. If you're using OpenShift today and you want to upgrade, we can help you do that. We can help you use OpenShift better, but we can give you those tools on a piecemeal fee, or we can integrate them all together and get it out to you in 3 business days. 3 days. Nobody else is doing that. So we're taking a different approach to how we're doing it. And Srihari is going to show a little bit about what we're doing and what we've engineered with Red Hat. If some of you guys saw the keynote that just happened, they highlighted our OpenShift integrated engineered solution that we did. We're the only ones to do it. We're the only ones to align with Red Hat formally at the next level with their cloud products. That's where they're going. That's where we're aligned. It's not the others that want to sell you storage or think they know what they're doing. So let's talk about what you need to have a great software production system. There's really seven items that you need to have, and as many of them as you can get as possible is important. But you probably can't get them all at once, but you want to get them all. It is possible, but companies are where they are today. And so going from where you are today to getting all 7 of these, or the perfect operation, is not going to happen overnight. Right? So what do you need? You need to streamline the software pipeline. Right? We all agree that constraints are there, bottlenecks are there, silos are there. We've got to open that up. We've got to identify those issues, and we've got to be able to fix those. Okay? Second thing is extending IT control. You know, how much control do we have over our developers in public cloud? Not a whole lot. The bills are going like this, generally ticking up, right? How secure is that? Well, we don't really know, but it's not as secure as if we manage it ourselves or did it in a hybrid environment where we could control and use our prem-based policies. You know, I mentioned a second ago that engineered infrastructure is really important because, you know, what consultants have done in the past or companies have done on their own, usually done by IT, until Amazon showed up and they started going out to cloud with automated tools, is they were duct taping stuff together that wasn't meant to work together. Right? And that didn't really help. That actually created more bottlenecks to some extent, but it looked good. And people thought, oh, we're really, you know, at the end of the day, people are still going into work on the weekends and building code and doing releases. Automating delivery. So there's 2 points of delivery. There's delivery from the IT side and there's delivery from the development side. Right? So an IT person has to automate infrastructure so that development can get it easily, as well as the application, that infrastructure, and let them kind of go set and forget if they can. Right? And on the flip side, then there's development who needs the workloads and applications. They need to get them easily. They also need to get them quickly, and they need the applications they want. So there's 2 forms of automation that you need to have to really have it. Because if you have it only imbalanced on one side or the other, it's not really that great. You're going to sort of lose what you're trying to do. And you need a proven platform. You need something that's there, that's been built, that's manufactured to some extent, that can be built, that's not a lock-in, that's extensible, that can grow, that can scale. And that's what we're doing with Jason and company and with Red Hat, as well, as you'll see. But as I mentioned in the automation side, you really need to make sure that whatever is accessed is easily consumed, right? If they're not using it, dump it back in the pool. Don't have these dead servers over here and these apps, and you got to go and install it, move these. I mean, there's no there's no rhyme or reason to justify that and the added cost, as well as the stress for IT. And then ultimately, IT needs to monetize it. Ultimately, to help the lines of business monetize it so it doesn't fall on the IT budget or even on the department budget. So some developers are in the cloud, and IT's going, great. They swipe their credit card, I don't have to deal with it, I don't have to expense it. That's not really a solution. I mean, that's sort of band-aiding, because at the end of the day, when you pull that code out, IT has to get involved in reformatting kernels, putting it through a production line again. Why would you produce a car? If you're an auto manufacturer, why would you produce a car on one production line, do it all complete except for the wheels and axles, move it over to another production line, and then finish it there? It doesn't make sense. The cars would be too expensive. They might fall apart. There's not a special QA process designed for that. So we're helping companies do one line of production and mass produce that inside the company and lines of business. And it takes a long time to get a full business. If you have hundreds of developers, some lines of business will pick it up. Some lines won't. They'll talk between themselves and they'll want to know more. IT becomes the champion. So our job is to help the customer succeed, not to sell servers and products. So with that, it's your turn.
Thanks, Steve. I don't know about you guys, but I'm just losing my breath just watching Steve go through all of that. This is what I go through every time I'm on phone with this guy. But good afternoon, everyone. So you saw all the big bang there. I like to slow things down, and I want this session to also be useful to you. You actually can walk away with the other side. So you saw what's going on, right? In general, the trends that are happening in the industry with software, and the fact that almost every industry that's out there is disrupting, is being disrupted by software companies, right? So software becomes a big competitive differentiator for almost every company out there. So if you're not in the business of software, you're still doing something with software, right? So what I want to do in the next few charts is to kind of like hit on the main points about the trends in technology and what sort of things that people should be aware of, right? If they want to sustain their business, grow their businesses, become competitive, become agile, right? So there are really, I think from a high level, there are three things that are happening. So you're here at the Red Hat Summit. One of the things that Steve didn't ask you is how many of you are, you consider yourself a DevOps architect or a full stack developer here? 2, 3, 3. Okay, not many, right? So the thing that's happening is everybody, who used to be a software developer that's focused on a particular piece of code now needs to be aware of the end-to-end, right? So this is one of the key trends that's happening. Traditionally, you had software applications that are monolithic, right? From an architecture standpoint, you had this big, bulky, SQL database, right? That's one big application. Of course, it's multi-threaded. It has so many processes running inside of it and so on. But when it comes to the packaging and delivery and maintenance of that application, right, it's a single big, gigantic thing that needs to be maintained, right, together. So it obviously brings with it a lot of complexity. One of the key areas being the fact that you cannot do independent module updates, right? When you want to deliver a quick fix on one of the security vulnerabilities in the code, you still have to go through this whole pipeline of integrating that patch, testing the application, make sure that there are no other issues and so on, right? So inherently, it's quite time-consuming, needs a lot of people to coordinate everything and so on. And then, of course, the validation cost. So in terms of how the teams are organized in in doing the development to QA to the delivery and maintenance, right? So there is an end-to-end cost to that. And to me, the biggest cost is really the time, right? The time to market. You want to be able to react quickly to your customers, right? You want to be competitive. So when you see another company came out with an interesting feature, but then in order for you to deliver the same feature or better, right, it takes you weeks to months. So right there, you lose your competitive advantage. So the trend that's happening going from this monolithic traditional software to the right is the so-called microservices architecture, right? So microservices, as the name indicates, right, they are just basically tiny pieces of your software, the same big monolithic application now refactored into a smaller scale module, and that also happens to be self-sufficient, right? Meaning you could actually factor out a piece of code in your software and turn that into a subset of the functionality, right? So that now it can exist on its own, and more importantly, it becomes a living entity that now you can actually take and run anywhere and be able to discover it and be able to talk to it and so on, right? So now, from a bulky piece of code to smaller scale modules, and by the way, it's not just the technical thing that's behind it, that there is also now the rearrangement of your development teams, right, around this microservices-based architecture, so that these teams are now focused on those smaller scales of code, right? But remember, the cost that comes with it, right, is the fact that now everybody needs to be aware of the service that they are developing and how that service will exist and how it will actually talk to the other services, right? So there is that awareness, right, that comes with it, that now you need to train the people to be aware of that, right? So you cannot now just develop the code in a silo and then somehow hope that it just magically works, right? Then the other piece of that is some of the cost that comes from the fact that now these services can run anywhere, right? They can run on your on-prem infrastructure or they can run in a cloud. So if the same piece of code is running on-prem locally versus running somewhere remotely, right, there is a cost of the network and the latency, and there's some performance penalty that might come with it and so on. So it is important that the microservices architecture, right, is really the future because this is how software gets much more agile and much more manageable, right? But on the other side of it it actually requires a little bit of architectural thinking, right, to make sure that you are compensating, for these additional costs that come with the flexibility, right, and the maintainability. But that's an important trend to observe. Again, like if you are predominantly in a software environment, right, whether you develop software in-house or you actually sell software outside, right? Okay, so then the next thing is this cloud native, right? So what is cloud native? And I'm sure most of you here know what it is. In a very high level, the idea is that when you develop your applications, right, are not thinking anymore of running it on a Windows laptop or running it on a server on your on-prem environment, but you're thinking, how is this application going to live in a cloud environment, right? So cloud by design comes with some interesting things. Number one, for the most part, you don't really know where your application is running, right? You only know what sort of environment it might be running in the sense that you know what the resource requirements will be for your application, how that application interacts on the network and what sort of storage, it requires, and if there are dependencies like a database server that needs to run somewhere else, right? So you are aware of those, but besides that, you don't really know physically where this application might exist, right? And so when you are developing the application and you want to target cloud as the primary target, right? You have to think of some architectural elements when you do that. And so this is where this trend, right? One of the things that is enabling this cloud native is containers, right? So everybody here knows containers, what containers are, right? So obviously containers are much lighter weight than virtual machines. So on the left, I have, again, drawn this picture of what that looks like from an overall stack perspective. You have hardware, you have a hypervisor operating system like a VMware vSphere ESXi or RevEdge, right, KVM, or you have a bare metal environment, right? It's not virtualized. You're running like a RHEL Enterprise Linux on it or Atomic Host, whatever. But the key here is you'll see, if you are running your workload, right, it actually requires a certain runtime, right? If it's a Java application, you need Java runtime. But then if you have multiple Java applications and each one of them requires a different version of Java, right, that's where you have the problem. You cannot run them all together within the same environment, right, because there are conflicts on libraries. So what you end up doing is you create a complete virtual machine with its own runtime, with its own libraries for every single time you have to deploy this workload. So again, very high on resource usage. So if you are a system architect, system admin, you're responsible for your IT. Obviously, you got to think of the cost of running applications and maintaining them as VMs. And of course, the resource utilization that results from it. But whereas you go to the right, and we talked about microservices. So each of these microservices, can be implemented as one or more containerized images, right, or containerized service. So in a container image, now you have everything that you need to run that application plus its runtime, and it doesn't conflict with anything else. And you could run multiple container images on top of the same OS instance, so you're sharing your operating system instance across multiple containers, right? And so consequently, you are improving your resource utilization underneath, right? So you get a lot more out of your hardware. Also, if you're, again, an IT-focused guy that's thinking of infrastructure management and the costs of managing infrastructure, right? This is an important trend. And the other key thing, and as we go to the next one, containers also become the unit of work, right, going forward between your on-prem and cloud, right? And why is that? Again, previously, you had virtual machines, and if you were to implement a hybrid cloud where you have your VM running on your on-prem infrastructure, but at the same time you want that VM to be run on top of Google or Amazon AWS, there is a process that you go through to basically prepare that VM image to run on AWS, right? So you go through, so first you create an Amazon EC2 instance, and then you convert that virtual machine through the, what they call as the image format, right? That's specific to running on EC2, and then you go through the authorization, and then so it is, much more secure and robust in that regard. But it's not a one-click type deployment, right? So you have to plan for it, and you have to go through all that. Whereas containers, right? So if you have used Docker, so if you know containers and you're a workload application developer, and you have containerized your images on top of Docker, that now becomes the unit of work that you could run on top of your local on-prem infrastructure, but then be able to take that same image, register it with an external registry or a public registry, and then you can go and deploy it on top of one of the public cloud providers. So much more, this is much more conducive to actually doing a real hybrid cloud, right? So this becomes the unit of work that you could migrate anywhere. So you get you get that portability with those. And this is how the future of cloud is going to be, right? All right, so with that, I kind of want to touch now on another aspect of it. We talk about software, but you cannot talk software in isolation because software needs hardware to run on, right? And all the great development that's happening on the software side, trying to get to more agile, way of doing things and implementing your DevOps CI/CD pipeline. It's all great, but consider what's happening underneath, right, at the infrastructure layer. There is a lot of development that's happening. If you look at things like software-defined, right? So there's software-defined networking, software-defined storage, and a lot of automation that happens at the IT layer. That's quite important to enable the other trends, right? So you want to run, a lot of containerized workload images. So imagine in your organization now you're stuck with hundreds of these tiny container images. How are you going to manage them, right? And how do you make sure that you have so many different requirements, right, from a resource perspective that can be addressed from your infrastructure, right? So at the same time, your software is becoming agile and really cool, and you can quickly deliver a new feature function to your customers. At the same time, your infrastructure needs to transform so that it can actually provide that pluggable environment, right, where you can now schedule and run hundreds or thousands of these container workload images, and if there are some of the images need high availability or they need persistent storage volumes, et cetera, there needs to be the right kind of plugins, right, that your hardware provides. Otherwise, you have a bottleneck, right? So you implement DevOps and go through the CI/CD, but then when you go deploy this in production, if you're still doing it on your age-old hardware architectures, you may actually be beating the point, right? So what we are focused on at Lenovo is, number one, obviously, we are an infrastructure company, we're a hardware company, we do servers, networking, storage, and switches, converged infrastructure and so forth, but we also decided, look, we need to unify the manageability of all of these devices from a single layer, right? And that's what we call Lenovo xClarity. It's a free tool. Anyone can download it and use it, and of course, we would prefer that you use it on top of Lenovo hardware. But the key is we created this very lightweight layer that understands our hardware, uses the industry standard APIs and protocols to talk to the hardware and manage the lifecycle. And then more importantly, if I actually skip this platform deployer layer for a second and look at the infrastructure as a service layer and also the workload orchestration layer, see, at the end of the day, your goal is to be able to support your users for running workloads, right? You could really care less unless you are the IT guy that spends all of his or her time managing hardware. You don't really care about the hardware, right? You want to be able to deploy these workloads, run them, and then at the same time provide the right kind of platform layer services, right, that your end user requires. And so, whether it's a container orchestrator, like, running your Kubernetes, container orchestration tool or something else, or you want to be able to provision and run virtual machines, right? Or you want to do bare metal systems. So those are the three main use cases, right? If you look at the data center and then the mix of workloads that people want to run. So the platform deployer, right, is the tool that we created, and it's open source. And what it does is really bring up your infrastructure, right, to the point where you can actually go deploy one of those infrastructure as a service layers on top, right? So imagine, you bought brand new hardware, and then you connected all the networking and did the system architecture and built up this hardware. You're spending anywhere from days to weeks, right, getting to a point where you could actually give the system to your users, right? So our focus with this platform deployer is to eliminate all of that gorp that you have to go through, and the objective being, regardless of what hardware you have underneath, right, it should take anywhere from an hour to 4 hours max, right, for it to be able to provision and run your workloads, right? So that's the focus that we are. So we want to automate. So the same principles of the CI/CD, right, we want to bring to doing infrastructure management. Okay. So this is the third trend. So we talked about what's happening with monolithic traditional workloads to microservices architecture. And we talked about what containerized workloads are doing and the future of cloud, right? And then the third piece of this is the infrastructure modernization, right? All of these needs to happen concurrently, right? None of these can happen in isolation, right? In order for you to really get the full benefit of this end-to-end implementation of your DevOps. And so, again, if you're a data center guy, you know that there were three pieces to the data center. There was storage, there was networking, there was compute, and this is a very rigid architecture. Once you provision it, you really cannot change things, right? I mean, yeah, you keep buying more storage and keep adding it to your legacy, but it's not really going to change things much, right? So we looked at how do we simplify this. And so at the very lowest layer, again, the hardware layer, hyper-converged. You may have heard of hyper-converged, right, which is essentially combining compute and storage into a single entity, so you don't have independent storage and compute, right? That's where the traditional SAN architectures and the complexity comes from. So hyper-converged has been the trend in the last 2-3 years, where companies like Nutanix and so on, they have gained a lot of momentum because people see the simplicity of this architecture, right? So you could start small, and here's your compute storage building block, which now you can add on to, and then you scale as your capacity and compute requirements grow, right? So that simplifies the architecture. But more importantly, because of the software-defined nature, right, of this solution, we actually have these rich APIs and the unified management capability, where now your infrastructure goes from being relatively static and unchangeable to something that's much more dynamic, something that you can reprovision with these rich APIs and programmability, correct? So that's what we're doing. So there is, again, this xClarity tool that provides that unified management, and then it also exposes all the REST APIs, right, that go along with it, and so that you can script with Python. So imagine, today you go to deploy an OpenShift instance, right, your Kubernetes scheduler on top of Google Compute or Container Engine. What you do is you first you request for like a 4-node or a 5-node or a 6-node instance, right, that then Google will take and it will go provision those nodes, and then it would go deploy the Kubernetes orchestrator. And once your Kubernetes cluster is ready, it will tell you, hey, here is the URL to your master node or your console that you can now go and access, right? So all of that happens in the background because you don't know what's going on there. So they would, pull up a bunch of nodes, and they'll go deploy all the Kubernetes services on them, and you have a service URL. The same type of experience, right? We want to drive it on-prem, right? Because for one reason or another, you're never going to have 100% of your IT outsourced to a Google or an Amazon, right? There's security issues, there's service level agreements that you want to meet, right? And so forth. So there's multiple reasons. And so for the part that sits on-prem, you want to bring the same type of manageability and end-user experience as a Google or an Amazon would give, right? And so that's where we are focused on providing that experience. And so these rich APIs and programmability enable you the same experience. So your user comes in and says, hey, I want to spin up a quick OpenShift instance for my test. I have a bunch of container images that I want to provision and test them. Give me like a 4 VM Kubernetes instance. And you implement this on-prem, and then through those APIs, right, you as a sysadmin can develop the right kind of scripting to go make that happen. And there are tools, there are open source tools, and by the way, this is all open source, so you could use those APIs. And then the more important thing is at the top, right, is the so-called orchestration engines, right? We talked about container orchestration like a Kubernetes. Or, if you are a VMware environment, there is vRealize operations or vRealize automation. The key is, today, if you look at any of those solutions, they don't have much hardware awareness, right? They deal mostly with the software, your virtual machine lifecycle, or your container lifecycle. But then you as a sysadmin, right, are scratching your head when, let's say, one of your servers loses a local drive and your storage suddenly becomes unavailable. So how, when you're spending most of your time at the orchestration layer, would you diagnose problems like those? And so our focus is we want to provide that level of rich analytics and the alerting and the eventing all the way from the hardware layer up into your orchestration layer. And at the same time, if there is an automation engine like the vRealize automation or even Red Hat CloudForms, right, that automation engine will be able to utilize those plugins and get that end-to-end visibility into the infrastructure, right, at that layer. So this is, to me, I think is the trend that you're going to see. And a lot of the infrastructure companies, let me rephrase it. A few of the infrastructure companies like ourselves are thinking of this end-to-end problem and trying to really solve this. Okay, so this is a little bit more on what the platform deployment tool does. Like I said, it's on GitHub. And today we created it to build up like an OpenShift infrastructure. And we are refreshing it now to support the new generation Intel systems with the Pearly CPUs. So more programmability, and it's all written in Python and Shell and so on. So it's quite easy to go. And this is the fourth one. The fourth one on the trends is the infrastructure as code, right? So we talk about programmability, but then what if like you want to kind of turn that into a sort of like a software development activity where you created a description of your system and then you want to maintain it like that, or you want to make changes. And so this now becomes a living source code, right, that you can maintain as the sysadmin, like your Python script or other your favorite tools. So there are those two layers that are supported on this. And then lastly, this is the example as telling about the integration from the hardware management layer up to the CloudForms Manage IQ. So we have open source on this as well, where if you want to manage, say, multiple data centers or multiple parts of hardware, each one being managed by a separate instance of Xclarity, you can bring them all together right at the Manage IQ layer, so you get visibility across the different environments. So I think I hopefully hit on the main aspect. So everyone should be aware of what's going on in the software, the trend from monolithic to microservices, containers enabling hybrid cloud, and then the platform level programmability that's coming. And so those three things will really enable this dynamic, agile IT environment that actually not only helps the developers, but ultimately it's going to result in the bottom line for the companies to become more competitive. So with that, let me pass it back to Steve for some closing thoughts on where we are.
So, thanks. So technologies and pieces and parts, all good trends, but to do it sometimes is overwhelming for IT guys or just an IT team, and to figure it all out and run it, and then the market changes on you. So what we did was, and part of our mission with Red Hat, and I'll talk about that in a second, is we engineered a platform that's scalable, modular, that you can add components to as you grow. Not just different components, but those components and depth with those components. So you're not monolithically throwing in traditional SAN storage systems to support with servers running X application for developers that you can't move around and in a composable manner deliver. So we engineered a base infrastructure hardware and software layer together, or hardware layer, Red Hat software. Ceph is also part of that. But as to today, bare metal containers are really the best way to go for applications that need minimal latency, like trading desks and things like that. So today, for hypervisors, it works very well. Hypervisors in themselves weren't custom designed for development. So to get them from an IT desk or an IT crew with the ticket sometimes takes a lot more time. But when you can spin them up yourself and the infrastructure's there, then your IT guy, or your developers are pretty much self-sufficient. And that's where you want to be, is self-service as much as you possibly can. And of course, automation has helped that. On the software layer, we partnered with Red Hat to build an engineered solution, and Intel to build this a software solution that brings it all together with CloudForms and Ansible automation, as well as with enterprise Jenkins, and then the public cloud. So what you have are the platforms and the software applications working together, as Srihari said. So you take what he demonstrated as trends and technologies, bringing it together. It's not hard-coded, so it's basically flexible, so it's off-reference designs, so that when we're with a client, we're trying to figure it out, and we're in that stage in the process. What we're doing is we're adjusting those reference designs to meet specific client needs. And again, no lock-in, so you're growing into it. We came to Red Hat and said, look, we've got to have enterprise-grade applications in here for security, for full features, for support, things like that. We can't just let them have just any application that may or may not be, what they're going to need as they grow and scale. So an enterprise platform needs enterprise applications. So we got together with Red Hat early last year, and we said, we think you guys have great product. It's proven itself to some extent, but we want to make it better. We want to grow it. We want to make sure that we design a solution that's flexible, that lets our clients get what they need to and not be locked in. So we designed a global collaborative relationship with them at the executive levels. Our president of the data center group, Kirk, and Jim Whitehurst are aligned and doing DevOps-related strategies together. We've joined forces to do technology research and product engineering, a lot of which we've done, and we're continuing to do as we engineer and bring other applications in, as well as hardware infrastructure layers, hybrid cloud layers. And then really it's to drive advancements in innovation. We want market-ready consumable solutions, right? What we showed you here is market-ready and consumable, right? Sometimes there might be some kinks getting it in, but when you're getting something in as a base foundation, you're done, and then you scale out appropriately as you grow. So that's what we're doing. We're the only OEM, major OEM, to have that type of relationship with Red Hat, no matter what you see in the Dell booth or others. We have engineered this, and we're going to continue to engineer it. We're investing a lot of time, effort, and money into it so that we can let our clients know that, here, we'll call you in 6 months when you need another block or another module to add on to it. We're there as a part of the continuing process to make sure what he was showing is together and working for the clients. So this is a quote that I'm not able to actually say the name of the company right now, but we put together a project for a very large financial services company in North America. You guys would know who they are, and their quote is, Lenovo and Red Hat engineered solution that enables us to standardize in a single hybrid platform, streamlining our pipeline processes and easily scale as we grow. We're able to unify our IT and software development operations and build better code faster, achieving true DevOps. And you wrap that with what we were talking about earlier to help companies get there, because it's not just the product that does it. Using the product right, it's not going to get you to where you need. And it's not duct taped together. A little bit on Enterprise Jenkins. So Enterprise Jenkins is now certified to operate with OpenShift. The CE version was there, but it's limited in capabilities. And to achieve true DevOps, you ultimately, one of the key pieces, have to achieve continuous delivery. It's proven that if you can achieve continuous delivery, you can, under the right conditions, meaning if you structured your team right, if they're on the same goal, same mission, in your short iterative development cycling or working on short cycles, that with mastering continuous delivery, you are truly in a DevOps operation. And so that's our charters to help companies do that. But you can't do that if your CI/CD process is waning or is bottlenecked. And so, freeware, premiumware, and so forth, limited function featureware isn't always the best answer. So this is an upgrade. Consider it, from a Boxster to a 911, maybe, or from an older Corvette that's fallen apart to a super awesome Corvette, right? The point is that to achieve what you need to, it drives CD adoption. That's one of the key points that I wanted to highlight. So, we're committed to continuing to innovate and add more applications. Yep, almost done. So lastly, we'll end it here. Is we have like 3 or 4 innovation centers around the world that are executive briefing centers, and they're a multi-million-dollar operation of systems and tools and software and things for proof of concepts, for demos, for client visits, executive visits, and things like that. We are happy to invite anybody that's interested in seeing this stuff actually operate in the lab and in our own environment. So what we do for also for clients who want to run proof of concepts. We actually we hook that up, and what we see is that when clients dig under the hood and they see it, they get it, and they actually ultimately have more success. I think it's what, 90% success rate when they go and they get their hands deep and nerdy before they, go off and buy product and then figure out how to piece it all together. So that's one way that we as a team are committed to bringing it together. That's it.
Okay. Thank you, Steve.
Oh, we had a few backup
So
slides.
we have probably 2-3 minutes for, you can download this rest of the deck and go through the charts.
So by the way, this is an eye chart. This is an eye chart of stuff. There's so many great points here, what we've engineered, why it's better, that we opted for an option as a backup because we didn't want to break it up. But so if you can read it, and again, you'll get this when you get the deck. These are the advantages of what our engineering did versus just taking OpenShift and throwing it on servers.